Okay, I just want to make this clear because a lot of people have asked stuff like this. A sphere has no edge. It has a surface, a face, but no edge. Here's a quick rundown from BBC Bitesize, and it's a resource for basic geometry. Faces. A face is a flat or curved surface on a 3D shape. For example, a cube has 6 faces, a cylinder has 3, a sphere has just 1. Edges. What I said a sphere does not have. An edge is where 2 faces meet. For example, a cube has 12 edges, a cylinder has 2, and a sphere has none. Vertices. A vertex is a corner where edges meet. The plural is vertices. For example, a cube has 8 vertices, a cone has 1 vertex, and a sphere has none. And here's a visual aid from Mum's Math, K through 12. 1 face, 0 corners, 0 edges. Very basic geometry. I genuinely am not meaning to condescend here, but this is very important when we're talking about things like the topological form of the universe. As for your other question, if you were in a sphere that was expanding, such as if the universe were shaped like a sphere and it was expanding, and you walked long enough along the surface, would you ever return to the same spot? Well, the answer is if you walked faster than the rate of expansion, you would, and if you walked slower than the rate of expansion, you wouldn't. And the universe is expanding faster than light, so yes, you could never actually physically travel in a way that you would return to the same spot. In fact, even if the universe were toroidal, you couldn't do that because the universe is expanding faster than we can travel. But even if you couldn't, if you were on a spherical-shaped object and you could not outpass the rate of its expansion, you could still tell if it were spherical based on the distance you already traveled. And you could do that by measuring angles relative to other positions in space. In flat space, if you were to construct a triangle out of 3 angles, then you would always add up to 180 degrees. In a spherical space, on spherical geometry, if you made a triangle out of 3 angles, they would always add up to more than 180 degrees. And this applies regardless of the triangle size, and regardless of whether the triangle is expanding in that curved space. Because when you make a triangle and you make that triangle bigger or smaller, the angles stay the same. So if you had an expanding flat triangle, it would add up to 180 degrees. And if you had an expanding curved triangle on a spherical space, then it would be more than 180 degrees, regardless of size, regardless of expansion. And then, using this triangle test, we can infer what would happen when 2 parallel lines go off into the distance in our spatial surface. If the angles added up to 180 degrees, then the space must be flat, which means 2 parallel lines will not intersect. They'll return to the same spot and never intersect. If they add up to more than 180 degrees, then we know the space is curved. And we know that they will intersect somewhere down the line.